implement the binary search algorithm by the use of recursion. Public and binary search. In the binary, we want to search an array. In search, we want to search an array, integers array, strings array. The best algorithm in the search, binary search algorithm. That is the best algorithm, the fast algorithm. I initialize an array here. I want to search for the key. I declare the key here and assign to, that is our key. I want to search for the 567 in this array. We call the binary search array. How to call? In binary search array have an arguments. First argument is the array. We pass the entire array to this binary search, and the second argument of the start point, because in binary search algorithm we have the start point, the end point, also mid point, and we have start point, also in the end point of the array, and also have the key. We pass these elements to this function, and here the start point of this 0 index is the start point of array, and that is the start point, and the end point, the start point is a 0 because we start from 0, and the end point of the size of array, the length of array is our end. 1 2 3 4 5 6 7. We have 7 elements here. Now that is our end point, array dot length. That is our end point, the length of entire array. When I call the binary search algorithm, index equal to, first of all, that is not a static method, that is a public local method. If the method or variable we declare as static, we can directly access this method or variable, but that is a not static method. We should be create the object or instance of this class, obj equal to new, that is object or obj dot, we call this array. We pass the array, pass the start point, pass the end point, and pass the key to this binary search. After that, in this case, first of all, we check the start and end point. Start is less than end. If the start is less than end point, in that case we binary search algorithm, and other case return minus, we return the minus index, because in that, if the start point less than end point, we can do our code here. In that case, in binary search we find the mid element of array. How to find the mid element? And mid is equal to, we add the start to end and divide by 2 the mid element of arrays. That is our mid element. In the binary search algorithm, we compare the mid element to the keys. If the key less than of mid element, we search for the left side array. If the key is greater than of the mid element, we search the right side array. That is the binary search algorithm. We break down that entire array by 2 arrays of each operations. In that case, we have another condition. If our key is less than numbers mid, in that case we call our function again, return binary, that is a recursive call. That is recursive call. If the key is less than numbers made, we pass the numbers to this array, pass the start point and pass the mid point, and we use the left side array. We filter the left side array. In that case, we pass the midpoint and pass the key also. Left side. If the key is less than numbers made, for example, that is our midpoint and that is our keys. Our key is less than midpoint. Yes, we use the left side array. We do not search for the right side array. We skip the right side array. We use the left side array. Start point is the start point, and the end up point of our mid, that is our end point. And also we pass the keys. In other case, else if the key greater than, in that case we pass the numbers. For example, that is our midpoint. The key is greater than, we look the right side array. We don't we skip the left side array. In that case, we pass that is the start point, of that is our midpoint. The start point is mid plus 1. We use upstart mid plus 1, and the endpoint itself endpoint, and we pass the keys. If these two condition is wrong, we know that the key is exactly equal to the midpoint. In that case, return mid. That is our binary search algorithm implementation. If you do not understand binary search algorithm, you search on Google and look in box, and first you should be know of a binary search algorithm. After that, you can implement this algorithm. Now I want to pass these elements to this array. First I want to pound. I want to run this program. What is the error? The error is this element spell error. Now I want to run this program again. Yes, found the 567 at index 3. Let's 567 is that 0 index, first index, second index, and the third index. Yes, that's correct. Now I want to pass the 2 here and run the program. S2 is at index 0. I want to pass the 900. Index C1, let's check it. 0, 1, 2, 3, 4, 5, 6, 7. Yes, that is the binary search algorithm by the help of recursion. I hope you are understand.